Welcome, students, to the notes on rewriting a quadratic in Vertex Form. So let's get into it. So if you have a quadratic equation written in general form, you can go ahead and rewrite it in Vertex Form. And we're going to have to do a step called completing the square, which we talked about in class, but this is just more examples of it being utilized. So first thing I'm going to do is I want to isolate any term with the x variable in it. So I want to get the x squared plus 6x by itself. So what I'm going to do is add 11 to both sides of the equation. When I do that, I get y plus 11 will equal x squared plus 6x. Now from here, I'm going to complete the square. So what I do is I take this b term right here, positive 6, cut it in half. Half of 6 is 3. So I'm going to put 3 here. But I'm going to square that quantity. And that's that's the process of completing the square. Take half of the b and square it. And that's where you're going to add onto your quadratic side of the equation. But really what I'm doing is increasing the right side of my equation by 9. So if I add 9 units to the right side, I also have to add 9 units to the left side. So we end up with y plus 20 is equal to the quantity, or actually equal to the quadratic x squared plus 6x plus 9. Now with completing the square, if I have x squared plus bx plus quantity b over 2 squared, then that is always going to equal x plus b over 2, that quantity squared. So that means that this trinomial here can be rewritten as x plus 3, that quantity squared, and they're equivalent to each other. So that trinomial quadratic is equal to this binomial quantity squared. And the left side still says y plus 20. So now all you got to do is subtract 20 from both sides of the equation. Take away 20 here, take away 20 there. And you get y is equal to the quantity x plus 3 squared minus 20. And there is your quadratic rewritten in vertex form. All right, example 2. We have a quadratic trinomial, but this case, the x squared has a coefficient of 3. And what we want to do is get that by, let the lead coefficient be 1. So there's a couple different ways you could do this problem. I'm going to start off by dividing both sides of the equation by 3. So you get y over 3 is equal to 1x squared minus 4x plus 13. Because every term in that quadratic on the right side is going to be divided by 3. All right. Now, once again, you want to get the x terms, the variable terms, I should say, by themselves and get rid of that constant. So let's take away 13 from both sides. And when you do that, you get y over 3 minus 13 is equal to x squared minus 4x. And now we got a complete square. So I'm going to add half of negative 4, that quantity squared, to both sides of the equation. So negative 4 over 2 squared, that quantity being squared, we same thing as negative 2 squared. And negative 2 times negative 2 is positive 4. So what we're really doing is adding 4. Add 4 to both sides of the equation. So the left side now becomes y divided by 3 minus 9, because negative 13 plus 4 is net result of negative 9. And on the right side, the quantity in the square will be x minus 2, that quantity being squared, and that'll give us this right here. So I'm running out of room, so I'm going to come up here and let me rewrite that. Y divided by 3 minus 9 is equal to quantity x minus 2 squared. So I'm going to add 9 to both sides of the equation. These cancel. Y over 3 is equal to quantity x minus 2 squared plus 9. And the last step is to multiply both sides of the equation by 3. On the left side, the 3's would cancel out. These are just 1y, which was what we want. And then on the right side, you're going to multiply everything inside the brackets by 3. So instead of having only one x minus 2 quantity squared, now I'm going to have 3 of those. Instead of adding 9, I'm going to add 27 because I'm going to multiply the 9 by 3. And you get your answer. In example 3, we have an equation that's already in vertex form. So that doesn't make sense because that's what we want our answer be in. So let's get rid of that. And let's have it in factored form. So let's say we have x plus 10 times x minus 5. So what you're going to do here is distribute and multiply the quantity x plus 10 times quantity x minus 5. So you can set up your area model here, set it up, solve it, and when you get done, combine like the linear middle linear terms, you'll get x squared plus 5x minus 50. And then you solve it like we did in examples 1 and 2. Add 50 to both sides. Now we got to complete the square. So take half of your b term, which is 5, so 5 halves. Square that quantity. You can leave it as a fraction, or if you want to convert it to decimal, that's okay. I prefer fraction, but you know what? Everything's equivalent. So 5 halves squared is the same thing as 25 over 4. So that's the amount of adding both sides, which is the same thing as 6.25. So if we keep on simplifying, that'll be 56.25. And over here, this will be the same thing as the quantity x plus 2.5 squared. Final step, take away 56.25 from both sides. These will cancel, and you end up with y equaling the quantity x plus 2.2 and 5/10 squared minus 56 and 1/4. All right, so now try the problems that you have for practice and see how you do. Good luck.